Okay, now we're going to work on the last question, how to figure out the accuracy rate of the logistic regression model. Okay, so in the lecture, I already emphasized that in order to figure out the accuracy, to calculate the accuracy rate, first of all, you need to define this threshold. So basically, you will predict the probability, regardless you are using the logistic regression or linear probability model. The predicted result is a probability. So we develop this threshold. Basically, we say, hey, if this predicted probability is larger than or equal to 0.5, we consider that as 1 means the outcome we care about happened. Otherwise, it will be 0. Consider that outcome it didn't happen. And after we do this 1 to 0 predicted value for the outcome we are looking for, compare that outcome with the actual result to determine did we got how many of them are correctly predicted, and total how many observations we have here to calculate accuracy rate. So therefore, we apply this idea to solving this problem. Okay. Question number G. First, the question is asking about the accuracy for the logistic regression, so we don't need to worry about the linear probability model. If you're interested, you can still doing it. So first of all, we need to fill in our column D here. The reason is that for the column D, predicted probability, and I just need to know for each one of them, given I know their year experience, the GPA, I need to do a prediction to know what is the probability for them to pass. Given that, and then my column E will automatically fill in the value 1 or 0, because here is the logic. So for this logic means if the value in D column is larger or equal to 0.5, the value will be 1. Otherwise, it will be 0. So that's literally how we define the predicted pass. 1 is pass, 0 is not. But given we are able to predict the probability. So in order to predict the probability, we need to leverage on what we did in question number D. So basically, this is the formula we're going to use to predict every scenario. What is the probability for that candidate to pass? So this is equal to EXP. We already did in question number D. Okay, parentheses beta 1 plus, beta 0 plus beta 1 times GPA's value, and then plus beta 2 times the year experience value. So now and then close the parentheses, and the parentheses divided by, follow the formula, right? Parentheses 1 minus, okay, EXP parentheses intersect plus beta 1 times GPA plus beta 2 times experience. Close parentheses, close parentheses. Like I said, we have 200 some observation. If you do this, it's going to cost you a lot of time. So therefore, I want to use the drag down function. What I need to do before I do that, I need to lock the cell for beta 0, beta 1, beta 2, right? Because they don't change. So I need to go into this I3 here. I push F4, function F4 on my keyboard. And this one, I just put the $sign to lock the beta 0, beta 1, beta 2 value because they are here. I don't want them to change. And the same here. And also, don't forget your denominator. Okay, so after I do that, I can push enter because I already locked beta 1, beta 0, beta 1, beta 2 cells. And I push enter. And I click this. Move the mouse to the right down corner and I drag it down. Okay, after I do that, as you can see, that is on. So you will be able to notice that the predicted probability sorry, instead of minus, I should be plus. Somehow I make a typo. That's why I said why got negative values. So it should be plus. Okay, let me drag it one more time. Okay, so now I'm able to obtain all the probability. As you can see, none of them are smaller than 0 or larger than 1 because it's the logistic regression. Okay, given you can see my column E is correspondingly changed. Any of the probability is larger than or equal to 0.5 become 1, as you can see the first 4, right? And then this one is less than 0.05, less than 0.5, therefore becomes 0. So those are my predicted value. Okay, so based on the equation, we need to know how many of them are predicted accurately and then how many of them are not predicted accurately. Okay, so how can we do that? So the best way to do that, to even use Excel, is what I usually do. If you don't know how to coding, just know Excel is. So you can imagine if A and the A is actual value, right? E is a predicted pass. So if they are the same value, regardless they are both 1 or both 0, the differences between them will give us 0. Okay. So if here is a pass, here is not pass, it will give me the difference of 1. Or if here is 0, here is 1, they will also going to give me the value that is that will going to give me the value -1. So none of them going to be 0, right? So therefore, there is a smart way to count how many of them are predicted accurately and inaccurately. Okay, so what I'm going to do is first I will type equal and I'm going to use absolute value. Why is that? Because later on, if I adding all the ones, because if the pass is 0, is the predicted pass is 1, 0 minus 1 going to give me the negative value. So my ultimate goal is I want all the incorrect predict give me the value 1. If they correctly predicted, the difference should be give me 0. So then if I adding this column together, that's going to give me total number of the ones because of 1 because indicate they are incorrect. So that's going to give me total value of the incorrect prediction, right? So just think a little bit. You can pause here to think about why that's the approach, or you can just follow me through, remember the methodology here. So I'm going to use the absolute value. I'm using the column A's value minus my column E's value. Like I said, if the prediction is correct, this cell going to give me the value of 0. If they predict incorrectly, so this column F value will give me 1. Okay, I push enter. As you can see, the first one predicted accurately. So I'm going to select this cell and drag it down, move the corner to the right down, move the mouse to the right down corner, and then let me drag it down. Okay, here they go. So you will notice that for the prediction that is right, it always gives me 0. For the second one, as you can see, the pass is 0. The predicted pass actually 1, so the difference gave me 1. So basically, all the cell that give me 1 means they did not predict it accurately. So therefore, if I adding all those 1 together, that will give me the number of inaccurate prediction. Okay, so if I want to know the number of inaccurate prediction, I just need to sum all these ones together. Okay, so among this 263, right? Let me go back to the case. We have 263 employee here. We have 83 of them did not predict accurately. Okay, so the total number of observation is equal to 263. Okay, so therefore the number of accurate prediction will equal to the total number of observation minus the number of the inaccurate prediction. That will give us 180. So now the question number, the last question, right? We try to understand the accuracy rate. Given the formula, accuracy rate is the number of the correct prediction divided by total number of observation. So therefore, my question number G's answer will be equal to the total number of the accurate prediction divided by the total number of the prediction observation. So that's going to give me 0.68. So if you convert to percentage, usually we like percentage. So our model accuracy rate is 68%. It's actually pretty good. Okay, actually pretty good. So the key here is, first of all, you need to know how to get as predicted the probability by plugging in the logistic regression model itself that gives us a probability. Second, and you need to know how to define that's 1 versus 0. Third is to figure out how to get in the accuracy, the number of the accurate predicted value, and using that divided by your sample size or number of observation, that give you the accuracy rate. So hopefully this will help you to understand, hey, how we measure the good enough fit for logistic regression. We are not using R-squared we saw in the linear regression model versus we are calculating this called accuracy rate. So the number of the data predicted correctly divided by the number of the observation you have. So again, in this model for the logistic regression, the accuracy rate is 68%.